In this video, I am going to simplify this complex number. Is given as a division of two complex numbers, 3 minus 5i divided by 8 plus 2i. I am going to simplify it and express it in the standard form for complex numbers, which is a plus bi. There is a standard process for doing this, and which is very standard and common way of doing this kind of problems. So this is in essence division of two complex numbers. In the numerator you have 3 minus 5i, and in the denominator you have 8 plus 2i. You can think of it as division of two complex numbers. However, keep in mind, division for complex numbers is not defined. But there is a way to simplify it and get a result for this division. The way you do it is this. You look at the denominator here, which is 8 plus 2i. We are going to find the conjugate of the denominator. So the conjugate of a number, so let's do it on the side here. Let's say 1 plus I is a complex number. The conjugate of that number is going to be 1 minus I. Basically, you switch the sign in front of the imaginary part. As you know, in a complex number, there is real part, like in the a plus ib or bi. A is the real part, b is the imaginary part. In this case, real part is 1 in 1 plus I, and the imaginary part is also 1 because I is the same as 1 times I. So you take the sign of the imaginary part and you switch it. If it's positive, you convert it into negative. If it is negative, you convert it into positive. For example, if you have something like 3 minus I, the conjugate of it is going to be 3 plus I. So now in our case, the denominator is 8 plus 2i, 8 plus 2i. So the conjugate of that is going to be 8, and we are going to switch this sign in front of the imaginary part. Is going to be 8 minus 2i. So to simplify this division of two complex numbers, what we need to do is multiply both the numerator and the denominator by the conjugate of the denominator. So the conjugate of the denominator is 8 minus 2i. Why is it 8 minus 2i? Because the denominator is 8 plus 2i. So I'm going to go ahead and multiply it by 8 minus 2i. So 8 minus 2i. Note, I have multiplied the numerator and the denominator by the same number, other than 0, of course, right? So it's kind of like as if you're multiplying the given expression, which is this, by 1. So you're not changing anything. The reason we did this is this. The reason we multiplied it so that we can get rid of the imaginary number in the denominator. If you look at the denominator, you see right now you have 8 plus 2i times 8 minus 2i. Now, if you remember your kind of basic algebra formulas, this is like a plus b times a minus b. So this is like a plus b, a plus 2i times a minus b, or 8 minus 2i. So 8 plus 2i times 8 minus 2i is like a plus b times a minus b, which is nothing but a square minus b square. So my a is 8 is going to be 8 square minus b is 2i is going to be 2i. Make sure to put parentheses around the 2i square. So it's going to be 8 square is 64 minus 2i whole square is 2i times 2i, which is 4i square. But remember, I square is negative 1, so it's going to be 4 times negative 1, which is negative 4. So in essence, this evaluates to negative 4. So we are going to write it as negative 4. So it's going to be 64 plus 4, which is 68. Now, however, don't worry about the formula so much. In case if you have forgotten this formula, no worries, just do FOIL it. So if you forgot the formula, you can just go ahead and multiply it out like this. 8 times 8 is 64. Okay. So 64. Then 8 times negative 2i is negative 16i. Then 2i times 8 is positive 16i. Then 2i times negative 2i is negative 4i square. Negative 16i, positive 16i cancel out. That gives you on here 64 minus 4 times I square. But we know I square is negative 1, which is going to give you 64 plus 4, because negative 4 times negative 1 is positive 4. 64 plus 4 is 68. It's the exact same thing that we got. So the denominator becomes 68. And the numerator 3 minus 5i, 8 minus 2i. I would recommend doing FOIL. So 3 times 8 is 24. Then 3 times negative 2i is negative 6i. Then do the same thing for negative 5i times 8 is negative 40i, right? Then negative 5i times negative 2i is positive 10i squared. Now you can go ahead and simplify it further. So 24 negative 6i minus 40i is negative 46i. Then plus 10 times I square. Remember, I square is negative 1. Then all of it divided by 68. So it's going to be 24 minus 46i minus 10 divided by 68, which is going to give you 24 minus 10 is 14 minus 46i divided by 68. You can break it down into two pieces. So it's going to be 14 over 68, right? Minus 46 over 68 times I. Now there will be some cancellation here, I think you can do. So 2 goes into 14 7 times, and 2 goes into 68 34 times. So it's going to be 7 over 34 minus, so let's see, 2 goes into 46 23 times, 2 goes into 68 34 times. So it's gonna be 23 over 34 times I. That should be your final answer. Now if you take this, that means 3 minus 5i and divide it by 8 plus 2i, okay, then your answer should be 7 over 34 minus 23 over 34 times I. And that should be your final answer. Now, here is a point that I would like to make, I'd like to emphasize. The reason the division for complex numbers is not defined the way it is defined for natural numbers or rational number or real numbers is that you can achieve the same result in a different way by taking into consideration the conjugate of the denominators, okay? By taking the conjugate of the denominator and by going through this process, you could actually perform division. So that's why division didn't need to be defined explicitly for complex numbers. I hope that this discussion was helpful. Thank you very much.